Thanks once again, everybody. Welcome to the GSE 101 track. This is session 3J, where we're welcoming Peter Plevka, who's going to open our eyes to a day in the life of a Db2 database administrator on zOS. So as we welcome the newer generation to the mainframe, this session hopefully will inspire some of them, or some of you, to take up a career as a database administrator. If you have any questions, please do feel free to put them in the chat, and we'll try to answer them. Some of them maybe throughout as we go through the session, and some towards the end as well, depending on time. And before I hand over to Peter, actually, just to remind you that I will put a link for the feedback into the chat as well. So please do provide your feedback, and we'll constantly try to improve our future presentations. So with that, Peter, I'll hand over to you.
Thank you very much, Atul. Hello and welcome. Good afternoon, good morning, good evening, wherever you are. Thanks for joining. My name is Peter Plevka from Vienna in Austria. For my whole professional career, I was working and still working on the IBM mainframe System Z platform, started in 1987. And normally I introduce myself very briefly. I will do much more introduction of my professional career on the mainframe platform, and especially on the Db2 database system later. But before, I'd like to start off with a little bit of a funny story from the old times. It's about mid to end of the 80s. The story is from a mainframe shop in the UK. It was told to me. I wasn't there. Mid to end of the 80s, in the summer, as it's hot, it's very important. It's the weekend and a lot of work to do in the data center, in the mainframe data center for this company. I'm not really sure. I think it was an insurance company. At that time, IBM mainframes models were the 3090, and a very powerful model at that time, and it needed water cooling. Air cooling was available, of course, at that time already, but not sufficient enough for the power of that machine. So you got the mainframe and adjacent to it a cooling unit with water pipes, circulation, and so on and so forth to cool the processes. And that story is interesting because that cooling unit broke down, stopped working. And when that happened, and I was at the same time starting my career in the same technology background, I remember that when that water cooling unit broke down, you had a certain amount of time, like 3 or 4 hours, to shut down the system, the mainframe system, completely under a controlled way until it gets fixed. But there was a lot of work, so it wasn't possible to finish the work in those 3 or 4 hours until Monday morning. The IBM technician was immediately informed, but it just took him like 4 or 5 hours to get there to fix it. So, problem, right? You just couldn't stop the system because there was important work to finish, and that would have been an outage and a problem to the business. So the technical team thought about the fact that it's the weekend and nobody's in the other offices of the company. And it was in the same building, they were in the basement. And then one person had the idea to run through all the offices because it's summer and it's hot and there was no air conditioning, and collect all the fans on all the office desks in the offices. And they collected over 100 fans and placed them around the mainframe to get more time without shutting down the mainframe and without the cooling unit to run until the technician from IBM came to fix the cooling unit. And to make a long story short, that worked. They had the fans around and it cooled the system enough, sufficiently enough. The IBM technician fixed the cooling unit. The mainframe never stopped working. They were able to finish the work. At the same time, I think it was like Sunday morning or so, or Sunday during the day, the manager came in, the IT manager came in because it was a big issue, thanked everybody in the IT data center operations team about their way to solve the problem. And then he stood in front of those 100 fans and said, and who of you wrote down which fan belongs into which office? Because nobody. And then on Monday morning, they had a huge fan sale in the office entrance area where everybody getting into the office could pick up his personal desk fan, because of course they just ran through the offices and picked them up. And true story, by the way. So the mainframe is available. So that's what I wanted to, that's what I wanted to start off with. Back to a day in the life of a database administrator. Thank you for being interested in the mainframe technology and in the platform, first of all, for those who are new. And before we start, I would like to tell you that I was 19 when I started in the data center, in the operations team. I never went to the university. I don't have a degree. I went to 2 years of IT school at that time. We're talking 82 to 84. I learned COBOL, I learned BASIC, I learned programming and the fundamentals. I did not learn anything about MVS at that time, was it called, and today it's zOS, the operating system, or Db2 or anything. I learned everything on the job. And I picked up the job of Db2 administrator at that time, later, that was early 90s, after I spent some time in the data center, which is a good way to start an IT career on the mainframe, by the way, because you learn everything, is Db2 was is in the center of each company, because data is the lifeblood of each company. So you are in the middle and you are connected to IT, of course, and you are connected to the business, which is very interesting. And by the way, if you know about relational databases, when I talk about it, you're not stuck to this platform. There is Db2 from IBM as a relational database, but there's also Oracle or SQL Server, which are similar, and that opens up a wider range. So I learned a lot by reading IBM manuals, by going to IBM classes, to going to user groups, but everything I learned was by doing and training on the job. That should just tell you that you can have an IT career. Now I'm with BMC as a mainframe technician with Db2 background for over 20 years. But you don't have to have a huge degree. And as we said, there is no university that teaches mainframe technology. In a way, there are a few in Europe that have classes, but that's just something I wanted to tell you. I have some notes here, but this is a little bit about me. I will get back to some of the things later when I talk to you about the things that you have to do as a database administrator for Db2. So enough fans. What do you have to understand? What is necessary as a foundation? Oops, what's going on? Okay, stop. No, stop. There is an automated presentation. I'm sorry. This is not good. Apologies for that. I ran through this. Oh my God. So hopefully it stops. Okay. Foundations. So databases are the supporting system for the data of your applications on the mainframe, relational databases, and the theoretical foundation of Db2 zOS is the relational model by Dr. Edgar F. Cope, created as he was with IBM in the 70s. And it basically defines columns, rows, tables, etc., attributes, everything that you need to understand as a theoretical concept that is the basis of any relational database, not just Db2 for zOS or Db2 for Unix or Linux or Oracle or others. You can read up, there are links here on Wikipedia about this person. Mr. Cord created 12 rules in 1985 to define a fully relational database management system. So he didn't define DB2. He was very generic about this. And he formulated these 12 rules, and they are known as the Cord's 12 rules. There's the link in it. And they set basically a standard for relational databases. Example, I won't read it to you, but rule number 5 is the comprehensive data sublanguage rule, which says a relational system may support several languages, but however, there must be at least one language whose statements are expressible per some well-defined syntax as character strings, and that is comprehensive in supporting all of the following topics like reading data, inserting data, deleting data, and that's the fundamental description of SQL. So this is something you have to understand. Number one, it's very important. The entity relationship model by Peter Chen was created afterwards, and I don't know what's going on here. These pages are moving by themselves. On top of Mr. Cord's theoretically foundation, I'm sorry about this, I can't stop this. Mr. Chen created the entity relationship model, and this is how data architects today are creating logical data models for relational databases. Logical data models are later transformed into physical data models because it depends which physical database you are going to use. Are you creating a model for DB2 or on the mainframe or on Windows, or you're creating it for Oracle or SQL Server? That's a physical model then. And there are slight differences on those systems. The logical data model will look the same for all of these. And there we talk on top of Mr. Cord's rules for a relational model, we talk about the relationships. There are one-to-one relationships between entities. An entity will most likely end up as a table in a physical model. There are many-to-many relationships. So it's a way to represent the reality of the world, of the business, as a model, how to store the data for this business, and then convert it into a physical data model, which then gets created into the database. So, sorry about that. I hope this stops now. These are two fundamental important concepts that are important, and it was told to me when I started to join the database administrative team. At the time, DB2 was new to the company I worked with, and also an insurance company in Austria. I got a book, so read this in the next month. You have to understand it. In DB2, now when we talk about a physical data model, database objects, for example, a table, an index, a view, etc., those are database objects, have to be defined and described. And that's the DB2 catalog, what you see right now on the screen. It's the metadata. It's the description of the data. It's how the table is called, how the column is called, how the column is defined. Will it hold character data or numeric data or whatever? And this is just a small piece of example of a few of the IBM DB2 for zOS catalog tables. There are very many these days in the latest version 13, and they're all related. So that's a very important factor. It's the relationships are important for you to understand. You have to understand the basic or the most important catalog tables. Of course, if you know all the tables, then you can also query those tables with SQL. It's nothing else than a relational database, what you're looking at, but it's the DB2 catalog. I know very many customers using DB2 on the mainframe around Europe and internationally, and all of them are using some kind of interface to to look into those tables, to look after a certain view. How is the view defined? How is the index defined, etc., without using SQL as a written language to code it, but as an interface to access the DB2 catalog without knowing all these tables and relationships. And we're going to get to those relationships in a minute when we talk about the tasks and the disciplines that a database administrator has to do on a regular basis or when certain incidents happens and so on. By the way, DB2, first release of DB2 was announced in 1983. At that time, it was considered to be a read-only database. It turned into a full transactional database with delete and insert capabilities and so on and so forth in the late 80s, and really got popular then in the 90s as one of the most popular database systems, relational database systems in professional IT. We might come back to this. So I hope this is now going forward. Oh my God. I'm sorry, what is going on? So anyway, I want to stay on this slide, please. Database disciplines, database administrator disciplines. There are three large areas. First, there are many little things that you might have to do. Before we talk about these, depending on the organization, you most likely are also involved in designing a logical database model with the architects, with the developers, with the development team that are working on an application or changing an existing application, enhancing it, and now thinking about how we have to enhance the data model. How do we store the data that we maybe have to get now into our application? Do we need an extra table? Do we need new columns in an existing table? For that extra table, which kind of access will we have for the data? That's how we will define our indexes, etc., etc. What's the primary key? How are they related to other tables that we need foreign keys, etc., etc. So the best thing is that you are involved in the design, in the logical design of a database. The more you are involved, the better it will end up in the physical design. That's the thing that you have to take care of as a DBA. That will have advantages for the users of the application and most likely advantages for performance and response time, because that's one of the things that a database system has to provide: fast access and consistent data. So these are the two things that's why we have database systems, to keep data consistent. So you always have the truth and you have fast access to read data or to update data or to insert or delete data. As a DBA, you most likely are responsible for all production data stored in DB2. So we're going to talk about backup and recovery management at the bottom. And that's another thing, that there is a lot of responsibility part of the job. I once remember now in my first days, I ran a reorganization job that comes with DB2. It's an IBM program where you can reorganize DB2 tables and resort them. So the data is in perfect sort order again, and it's basically a cleanup that you do occasionally when necessary to improve the performance and response time and the CPU usage of your application accessing this table. Anyway, I coded the JCL, the job control language, wrong. The job ended, not normally, abandoned, but then the output data set that was going to be resorted was deleted, and suddenly I did not have a database. So we had to recover this table, which was a little bit of a stressful situation. So another thing that is very important to learn as part of managing a database are so-called utilities. You get them with IBM, with the DB2 license, and it's batch programs that help you handle the data. Backup, of course, you do backups of your data at home, privately. You have to have backups for your databases, for your DB2 data. Some people need the data for other purposes, so you need to unload the data and maybe load it into a different database somewhere else. Same DB2, but different subsystem, different catalog, or even a different format. So there's unload and load utilities. There's this reorg utility, the cleanup that I talked about. And I will talk about the optimizer in a minute. So there are a bit more. You have to understand them in general, have to understand how to use them. And then, of course, if you come into an organization, understand how they are used in that organization and why and how frequently, et cetera, et cetera. So this is important. So those are the three main disciplines I would like to talk to you about. Change management. This is about changing applications. Remember, DB2 is a subsystem, as we call it on the mainframe platform. It's beneath something bigger. So this is your business application, your COBOL transactions, your batch programs written in COBOL or whatever. They are the master. They access DB2 through SQL embedded in the code and get data or delete data or update data. Changing an application means sometimes the need to change the physical database design. And that's what I mean. And that is sometimes a complex task because remember the DB2 catalog and all the relationships. It's a monolithic thing. It's not modular. Once you define your database, your physical database model, you have your database, you have a database, you have physical table spaces, many tables, even more indexes, even more views, and so on and so forth. Can be thousands of those objects. And then the thing is, why is this important to understand, and why is this a task? A task that is maybe frequently every month. Some companies run changes maybe only 4 or 5 times a year. Some companies have fixed change and release cycles. It depends on the business, on the industry, on the individual application that needs changes. Depending on the change, DB2 needs to change. What's the problem? Why is this such a challenge? I compare it to a house, and you renovate a house. Imagine it's quite easy just to repaint the walls, right? So it's not a lot of effort. You can still stay in your house, so the data can still stay in the database. So there are many types of changes that are necessary based on the application code change that the physical data model can be changed basically on the fly. So that's easy, but it's necessary to understand that if you have, for example, version 3 of your physical database model in a pre-production environment, and next week this version 3 will go to production, which is currently version 2 of your application and physical database model, that this is not most likely not just one little change, not one room that you repaint. It's maybe 10, 15 more. So they have to stay in sync. The physical database model has to be in sync to the application. So if the application goes live in a week and a table or a column or a view is missing that this application now needs in version 3, problem. Phones are ringing. So that's your task, to keep those versions of physical database models in sync. And the definition is in the catalog. And that's what I mean here. So that's easy. There are changes that are more disruptive. Imagine you want to remove a wall and so on. So you might need to turn off the electricity and turn off water if it's a kitchen or whatever. So this is an interrupt. And sometimes, and I have this picture like this, it's like creating or adding a new bathroom or even adding a new floor to your house. So that's that picture. So disruptive changes, like changing the physical file system underneath the tables in DB2 for zOS. And you can't just change it. You have to unload the data, change it, because all the dependencies need to be changed, and then need to be considered, and then reconstructed, like in this picture. And that's basically a schema change process. Oh my God. A schema change process. A very important task for DBA to understand, very generic. There are two phases in time. You see the timeline here. When I talked about my example, in 1 week, version 2 will turn into version 3 of your big business application. And over the last 2 months, a lot of changes accumulated in many different programs of version 3. They are tested, now they are tried, they are ready. And based on those changes, there are also quite a few changes to the physical database model. So you need to specify those changes, analyze those changes. Basically, everybody needs to create some kind of script based on the rules of DB2. So if you remove the roof, and you have to rebuild the house as it was before in the first floor, and then build the second floor on top of it. But before you can do this, you have to get rid of the first floor and remember all of this, that there was a kitchen in the first floor, and so on and so forth, exactly as it was before, because most likely only a small part of version 2 will, or let's say only a small part of the application will make version 2 version 3. So there is an SQL called Alter, which is the new paint on the wall, or if it's more disruptive, you have to get rid of the data, drop the object, the table, for example, recreate it in version 3 and reload the data in the new format of version 3. So it's complex. I know a lot of customers, again, in this world, they're using automation software from many different vendors to automate this because it is too easy to forget something, and then there's a problem next Monday when version 3 goes into production. And then there is a second time phase where you actually collect all these changes and then actually execute those changes and change the database. And that needs to be catered for. And that's normally a time where the database is not available or only partially available. We call this database maintenance, and this must be normally it's scheduled. People know about this, etc., etc. And of course, you want to avoid. And with DB2 today, you have a lot of these changes available to do online without stopping the database, but still making sure that all of those changes are there for version 3 are important. And that's the schema change process. And don't forget, plus the orange box here, SQL. SQL might also change, because if you add a column to a table, you most likely want to read it, right? Because why would you add a column to a new table? So you will change your SQL embedded in your code of your application too. That changes, and those changes can also, even though the physical database design is correct, those changes in SQL could turn into bad performance, long response times on Monday morning. So even though all the physical things are there, the house looks identical, just with another floor on top of it, everything's fine, but I really can't get access to it because I lost the key, for example. So SQL change management in a very similar way is necessary. DB2 is super. DB2 is super because it is a relational database, and if you remember, Mr. Code defined the need for an access language, which is disconnected from the type how the data is stored, which is structured query language, SQL. Before, you had to know how data was stored in a file, and then you had to write your program exactly how to access the data. You don't have to do this. A huge advantage, super simple. SQL is based on the set theory. We all learned this in school. It's easy, even for me, without having a degree of a university, and therefore it's also easy to do things the wrong way. SQL is the business of application developers to read data, delete data, update data. And today it's complex. The standard, the worldwide standard is very thick. A lot of things can be done. It's almost a procedural language already, basically, and therefore performance management is important because, as I said, even if the change that you applied next week is great and is working, and your physical database model is there, with the wrong SQL code, you can cause a transaction to run 1 minute instead of 1 second very easily. And there are 3 areas of tuning potential in DB2. I would say 75%, the white area, is in the SQL code. So if the performance or the response time of a certain SQL statement is too long, and that's described by the end user, there is no time limit. But if this is causing a problem or it's getting slower as last week, then SQL is 75% is the reason, or bad SQL is the reason. So that's important, that you need to understand SQL. Of course, you can write the best SQL. If you don't have an index on the column you want to read, it's going to be slow. So that's the red piece, database design. It can have a huge impact. So of course, if there is an SQL in a new part in the version 3 of the application and it reads data in a new way, you might need an additional index to cater that. Indexes are performance tools provided to you by DB2, and you have to understand how explain in DB2 works. It's a process that you get with DB2 where you get output from the DB2 optimizer written by IBM that translates SQL into executable code for DB2 when you bind your program. And then by understanding this explain output, you understand how this particular SQL accesses DB2, and you will understand how to change the SQL to make it better or faster and cheaper, or how to change the physical database model, maybe to add or change an index. And last but not least, there is the database infrastructure, which is the DB2 system, which has a lot of parameters. They are stored in a DSN-ZPAR member. It's a file that is read when you start up DB2 on the mainframe. No details here. There are a few things that are necessary to have DB2 perform well, like data buffers, for example, and other things that could cause performance degradation, bad response times, even though you have great SQL and great indexes and whatever. For example, also concurrency is an important part. How many things that run in parallel, many programs that run in parallel, accessing the same table, should behave. So that's also an important part to understand in order to understand performance and response time. Where to look? In all of the work that runs on the mainframe, hundreds of applications, thousands of database tables, millions of transactions, depending on the business you are running the mainframe on, we have monitors. And I will not talk about monitors. It's software that look into the mainframe systems, or also DB2 in real time. They see the exceptions, those things that are above the red line. But actually, down there lies the real tuning potential, because it's the massive amount of SQL raining down on DB2 during the day and night through online transactions, batch, that cause a lot of work for DB2. Yes, of course, you need to have a process to check the exceptions, and they will be identified, and then you can look at it, and then you might want to change the index or the SQL to avoid those exceptions. But those are just very few. But if you look into tuning, you should look at it as the whole SQLs that run, every SQL that run during the day, millions, it's like finding the needle in the haystack, right? So the haystack is all of the SQLs that run during the day. What are my tuning candidates? So first, think about how to identify tuning candidates. And often a tuning candidate is not the one transaction, the one SQL that runs for 3 hours and could run in 1 hour, but it only runs once in a month, which might be a good improvement for the business, because if it's done in 1 hour, other things can start earlier. That's good. But often it is those very many small transactions. We're talking about Db2 SQL that runs in sub-second, millisecond time to return just one record through an index very, very fast. Everything's in storage and in buffers. So that's super, super fast, but hundreds, thousands, millions of times during a day. And a small improvement there could also reduce especially CPU time. Because the response time of such a short transaction is going to be short anyway. And if there are many, time accumulates, and then the end user will recognize. But today, everybody pays CPU time to IBM. So the more CPU you use, the more you pay, and almost everybody. Therefore, Db2 is often #1 cost contributor and CPU user on large mainframe systems. And if you are able to identify those transactions, those programs that use SQL in a very short and fast way, but can improve those still, because there are so many, it will still save a lot of resources in CPU. I already talked about it. You can improve the SQL in the application program. Of course, this needs to be tested again, etc., etc., in order to end up in production. Or you can improve the physical data model, like indices, changing indices, etc. So that's why understanding the explain output, that again, the explain is a program that you get from IBM with Db2, and it gives you output about how the optimizer of Db2 translated the SQL that was embedded in your COBOL code or PL1 code, wherever, and tells you how Db2 will access the data for this particular SQL, and then you have to make sense out of it and identify possible changes. Because sometimes changing an application SQL is very costly, because again, you have to go back to the application developer. This needs to be tested. Is it still working? And is it improved in performance? You should have a process to compare before and after, etc., etc. Last but not least, let's talk about our version 3 that comes in a week, right? Version 3 comes in a week, and we move, and we have a lot of people, and you are involved in performance tuning. There are 55 new SQL statements coming with version 3 on top of the 25,000 that are already there in version 2. They are tuned, they are quality assured, they work as they should, they are fast. We're happy. But things are changing over time. After next Monday, this might run very smooth and fast. What is changing? Well, the data, the underlying data in our tables is changing. Data gets loaded from outside sources, you get more data, or it gets deleted. So you remove data, you update data moves around. So that's the cleanup process I was talking about, the reorganization. So basically, that's also an important task, not just to be happy, well, version 3 is working. You have to have processes around to make sure that the SQL stays as performant as it was when you first moved it into production. Backup and recovery management. Last big topic. Classic disaster recovery is very rare. So I'm talking about the storms, the earthquakes that destroy, the floods that destroy a data center. And by the way, this picture is a real German data center, I think at the River Rhine. That was, I think, like 8 or 9 years ago. I'm not 100% sure if it was a mainframe data center, but it's an IT data, it burned. So this is the disaster we're talking about. And everybody that you currently already work for, or you maybe decide to work in the future because they run their applications on a mainframe, and you like to be a DB2 mainframe, DB2 for zOS database administrator, spend a lot of money to protect against this. Every large organization has a second site. So you have a physical location, you have a mainframe, and you have a second mainframe that you normally also use, maybe some kilometers away or maybe even further away. There are great technologies out there, mainly from IBM, to connect these and to have these working as a cluster. In the mainframe world, we call it Sysplex. Anyway, to protect, so if there's a flood in this city, you don't have a flood in the other city, so you can still continue your business. That's the whole idea. And the flood actually comes into the basement where your mainframe is. That shouldn't be the case anyway, because those rooms should be protected. But anyway, this is very rare. And here is another story because of the but. So a lot of money, a lot of resources go into protection of this. This is good and important, but those things are rare. What happens much more often is it stops. Very good. I can tell the story. I was involved. In 2003, a large bank in the Nordics, in Europe, had an outage because a mainframe outage, but mainly causing DB2 data to be corrupted, and then there was the need to recover. The outage caused almost a week of outage. The business went on, and then during that week, they restored individual transactions and so on and so forth. But why did it happen? They had large disk racks. We're talking about 2003. So disk arrays, terabytes of disks, of course, for mainframe data. DB2 data was on these disks. And the power supply of the disk array stopped working. No problem. This disk array had built in a second power supply that immediately took over. No interruption, nothing. The team there, the IT team, the operations team didn't even recognize, because the system called the technician automatically. He rang the bell. People at the bank IT center didn't know what's going on. Let them in and said, well, yes, one of your arrays, the power supply broke down. I'm here to exchange it, because they were currently running on a single supply. That happened a few hours afterwards. So the technician opens the door and pulls out the wrong power supply. So that's the sound of the Star Trek when the Death Star goes on. And suddenly, no power, in flight of business. So that's how data got corrupted. It was a very difficult situation. A lot of data was being recovered automatically by DB2, which is a great process, by the way. But still, there were some inconsistencies because of that human error. So that's what I wanted to show you. Someone accidentally deleting data. Star Wars, yes. Did I say Star Trek? Oh, of course not Star Trek. Star Wars. Sorry about that. Oh, this must be deleted from the recording. Human error. Someone accidentally believes I'm on the test system with my data. I delete my data because I want to test my program, but I was accidentally connected to the DB2 production system. As a DBA, you have to be even more careful, because you most likely have access to these systems. Application developers normally don't have access to production databases, but you will have. You have to be very careful with that. So often it's many different reasons why things break, and you have to recover. So you're going to be, and that's going to be almost the end of my session, you're going to be responsible for production DB2 data in your job, which is a big responsibility. You have your backups, you have to manage your backups, you have to make sure that when someone asks, you can say, yes, we are recoverable. We have everything together. And at the time I learned about DB2, I went to a 5-day class, 4.5-day class at IBM in Vienna, Austria, just about restart and recovery. And it was very impressive because this is one of the most slick systems I ever understood, how DB2 keeps data consistent, even though there is a problem like the one I just described, where, let's say in a bank, you transfer money and you have a DB2 program and an SQL that subtracts the money from this account, and if the target account is in the same bank, so it adds the money to the other account, it reads the two records, and in the middle, it gets subtracted in the middle, power goes down, someone does something, and anyway. DB2 is able to restore the data to a point of consistency where it automatically recognizes that, hey, there was a transaction which wasn't finished, so it was not committed. So I have to roll it back. So I have to remove that subtraction from the source account to make the data consistent again and tell you about it. And then, of course, you have to rerun the program or the transaction again in order to finish the transfer of the money. That's your job then. But DB2 does that automatically. It does not leave the data like it is, which would be inconsistent. This is just a very simple example of how this restart process works, and also the recover process of data. If something happens and you have a backup from yesterday, you have logs that DB2 writes about the inserts and deletes and updates, and they get applied, etc. So this is job number one, and you have to understand that, because if you are in a recovery situation, you are under stress. So if something goes wrong, and you're not the person who did it, but anyway, even if you are the person who did it, that's an advantage. But something is stopped, phones are ringing. What happens? Your manager is calling and asks you, when will the database be available again? Because then you can start the application programs, the CICS regions again, etc. You are under stress, so prepare yourself. You might know that large IT organizations do disaster recovery tests like once a year. It's like the fire station to run tests and trainings. You should test this and train this. You should have processes in your drawer that describe what to do for a certain recovery or document all of this. And often, too often in IT, but also in the mainframe world, it's like that knowledge of this is in here, in the brain. And then some disaster recovery tests need to be done with certain people not attending, testing the ability of an organization to recover the IT without special knowledge. So these are just some examples. But you see, as a database administrator, you are in the center of a lot of things. Again, you have to understand the business and the application in order to be able to help with performance, with backup and recovery, with change management. And you have to understand the technology on the other side. And that's why I was a DBA for more than 6 years. And of course, I continue to work with DB2 software after the mid of the 90s until now. Still trying to keep up with all the changes. So resources, I have some links for you for afterwards. That's the getting started documentation I think I mentioned at the beginning. I did some search. There are some great YouTube tutorials which are impressive, longer than this session. Links are behind it. There are some great blogs if you're interested in the history of DB2. And there is also a blog about database changes and recoverability. So they're all connected to the topics of today. And then also some more to read about Mr. Cole's relational model for you. and to consume afterwards. This is now the official end of my content for this afternoon. And I don't know if there are any questions regarding the content. Still, we have a little bit of time.
Thanks, Peter. That was, I think, really insightful. And I think it gave a good baseline for the responsibilities of a DBA on the mainframe. Some of it quite scary because you have a lot of responsibilities as a database administrator, but rightly so, to look after the data organizations hold. So I invite everybody now to please do unmute and ask questions if you have a question or a comment on anything that Peter has shared today, or please feel free to add that into the chat box as well. So from my point, Peter, I heard you talk a bit about storage and buffers and things like that. So can you just explain a bit about what is the impact of storage and buffers on the performance of a database?
Well, in general, when you want to have fast access to data, you want to have data in memory or in buffers. So buffers and memory are the terms that we use on the mainframe. In the DB2 world, we call them buffer pools. And you define them when you start up DB2. And today with the Z16 hardware, you can have, I don't know how much memory, 4 terabytes or even more in memory. We're not talking about disks. This is memory. So much faster to access. So ideally, we want to have, if performance and response time of repeating transactions is important, and data is reread or reread multiple times as part of the business process, maybe, then it's a must that this data resides in a buffer or in memory, because once it is read the second time, it's not brought in from the disk, even though it's super fast and it's directly connected to the mainframe. It's in the memory. So that's the difference. Storage for me is disks. So today, still at the end of the day, it's spinning CDs. But of course, modern storage systems have huge caches, which is again memory that simulate physical disk for the operating system, zOS. Still, when we compare it, accessing memory is super fast, and then accessing a disk or data on disk is just taking much longer. And again, it's the little things that repeat thousands of times. Then you need memory.
Excellent. Okay, so that really explains why DB2 is probably one of the most popular databases still on the mainframe when organizations are running millions of transactions a second. So that all makes sense to me. So once again, to our audience, are there any questions you have at the moment or any comments you'd like to make? People are thinking.
Peter, can I ask a question?
Go now, go on.
Yeah.
What's the I know you've given some examples today, obviously, like about the fans earlier. That was quite a funny, interesting example. But have you ever had any other like moments where you've thought, you know, this is really serious, like this could go very badly wrong or has gone very badly wrong, and you know, how did you stay calm under pressure and then resolve that? Because obviously it's all, I think a lot of the times, you know, people like to think of how they're going to act on their best day, not on their worst day.
Okay, I gave those 3 examples, but I now remember one situation when we talk about a batch job, or it was, I don't know if it was a batch job. I was really scared. It wasn't a batch job. It was actually a TSO online transaction. So IBM gives you a time sharing option to access the mainframe. This is not a DB2 topic. And you have a green screen interface to data sets and programs and access to DB2. So if you buy DB2, you get DB2, you get the so-called ISPF interface called Spoofy. And it's like a menu where you can manage DB2, you can enter commands, etc. And I ran a query. I ran an update. I think it was requested by the development team. And I did something wrong with the SQL, and we just ran it through through spoofing. So basically, we coded the SQL, and then you press enter, and the screen is blocked, and it executes. And the developer says, yeah, it just updates a few records, and it didn't, because we missed something, and it suddenly updated the whole database, and it took forever. And then I was scared because you couldn't interact. You could just, what's going on? Why is it blocked? It should be done in a second. So basically, what I learned by that, what we did, we canceled my session so that another person access to the console canceled my individual session. So what happened then? Automatically, Db2 started to roll back all the changes that already happened from my wrong SQL, and we ended up with the status of before, which was very good. At the end, I was, whew, but during that time, I thought, oh my God, we missed that in the SQL, that's wrong, and it's now updating all of the wrong records, and how we are going to fix this. But then, because of canceling the user out of the system, Db2 recognized it and rolled back everything. The cancel operation took as long as the forward update already took. So that was another situation I remember now that was quite scary, but turned out being good at the end. Then we fixed it, and then it ran in 2 seconds.
Always valuable to have those learning opportunities.
That's a big learning opportunity, because then you learn how to run, and you understand how this whole monster of Db2 works, positively seen. It's not a negative monster. It's perfect.
And you never make the same mistake again.
Oh, yeah, that's another thing.
Okay. One more question, Peter. Do organizations normally take in, for example, graduates directly into the organization as a database administrator, a trainee, or would you have to go in as a developer, learn the fundamentals of Db2 before you move into that role? How does it work? Do you know?
Okay, so even though I'm from Austria, very small country, few mainframes, I work a lot in Germany, second largest mainframe market on this planet, and a lot of customers. I see all kinds of situations. So there is no such rule. I see many large organizations getting young people into mainframe IT in general, and sometimes I have a meeting and I meet with the old guy, and then there are 3 younger guys between 25 and 35, and there's the zOS sysproc trainee, the Db2 sysproc trainee, maybe the network guy, for example, or others, or developers. So I don't see a pattern. I think large organizations act, and even though the skill situation that we often describe in the market in general, oh, we don't have any more mainframe skills anymore, and no people come out of school that want to work there, is a little bit misleading. We will have smaller teams of knowledgeable people on the mainframe, but I started 1987, and I was 19 years old. I had 0 mainframe knowledge. I knew how to code a BASIC and COBOL program, and I knew how to convert hexadecimal to binary. That's what I learned in the school. And I learned it the same way as people that joined in the last 5 years a mainframe team. So, as I said, by learning and training on the job and so on and so forth. But I don't see a pattern in terms of the position they are starting at.
Great. Thank you very much for that.
They always have a mentor. So there's not like, okay, the zOS guy is out, has retired, and here's the young guy. That's not happening. That's not what I see. It's always
there needs to be a crossover and handover of knowledge of some sort. Yeah, good. Okay, excellent. So I think we're top of the hour actually now. So I think I'll close the call now. And just a reminder to everybody, please do complete the feedback form for Peter, so that we can learn lessons and make sure we do a better job next time as well, even better than today. And if you do have any questions for Peter, Peter, I think you got a final slide. Can they contact you directly? Or
yes, of course. I'm sorry. Yes, here they are. Please get in touch with me. My door is always open. My job at BMC for the last few years is enablement, is training for other people who join the BMC mainframe team. So glad to help you out to answer your questions.
Fantastic. Okay. Thank you, Peter, and thank you everybody for joining us today.
Thank
See
you.
you in the next session.
Bye.
Bye-bye.